Hai, Assalamualaikum to Dr. Mahadi and Dr. Afisha. I am Mimi Suraya binti Mahadi, and today I will present my proposal for BDP1, which the title is Characterization of Zinc Oxide Nanoparticles produced by Laser Ablation Technique. This study will be conducted to produce zinc oxide nanoparticles in different pH aqueous solution. Different medium will give a different properties of the nanoparticles, especially with their size, morphology, and also aggregation. The data will be analyzed using FASM, EDX, and also UV-VIS.
There are few objectives of the study. The first one is to produce zinc oxide nanoparticles by using pulsed laser ablation. The second one is to analyze the effect of different pH media as the medium on the size of zinc oxide nanoparticles. The third one is to analyze the effect of laser ablation time on zinc oxide nanoparticles. And the last one is to characterize zinc oxide nanoparticles based on their size, elemental composition, and also morphology.
There are few different techniques utilized to produce zinc oxide nanoparticles. For example, we have solder chemistry, thermal vaporization, solid state pyrolysis, magnetic sputtering, and also molecule beam epitaxy.
There are few disadvantages of those techniques that I listed before. For example, we have thermal vaporization, which it will include additional cost for the equipment. The second one, we have solid state pyrolysis, which is more complex than other alternative, and the cost of the raw material is more expensive.
It has been decided to use pulsed laser ablation technique for the production of zinc oxide nanoparticles. This is because of its advantages such as minimal heat transfer, cost-effective solution for many different processes, and also safer and environmentally friendly. The process begins with the material and sample preparation such as cutting, cleaning, and also sample drying. Okay, for the second stage, Q switch and NDX laser with wavelength of 1064 will be used for laser ablation. Okay, the experiment will be carried out in different pH solution with the different ablation time from 5 to 25 minutes with 400 millijoule.
As you can see here, this is the figure of the experimental setup. Q-switch NDX will be used as the pump source. Pulse NDX laser used to irradiate the samples at normal incidence, which the laser beam can be either focused or non-focused onto the sample. It has an interaction between incident beam of radiation once it scatters. For this process, Q-switch NDX laser with 1064 nanometer wavelength will be used. The distance between the laser and the sample will be setting about 10 cm, and the experiment will be carried out with 400 millijoule input energy, and the ablation time will be varied in between 5 to 25 minutes. The sample's characterization that will be employed in this study consists of three different properties, which are surface morphology, optical properties, and also elemental properties, and these properties will be measured by using three different equipment. The example of equipment that we will use are field emission scanning electron microscope, which is used to envisage a very tiny of particular topography on the surface or whole or fragmentary objects. The second one is ultraviolet and visible spectroscopy, which is a appropriate tool to characterize the properties of metal nanoparticle in particular size and shape of the metal nanoparticles. The last one is energy dispersive X-ray spectrometer, which is a powerful technique used to verify the elemental analysis as tiny as cubic micron of. I guess that's all from me. Thank you for listening.